afternoon, students. Welcome back once again to the mathematics class. So, in today's lecture, you are going to solve miscellaneous examples of chapter 9, that is differential equation. So, the first question in the miscellaneous exercise is question number 1. For each of a differential equation, given below, indicate its order and degree. Indicate its order and degree if defined, right? If defined. So the first one is d2y upon dx square plus 5x into dy by dx whole square minus 6y, which is equals to log x. Second question, dy by dx whole cube minus 4 times dy by dx whole square plus 7y, which is equals to sin x, right? Question number 3. d24, it is d4y upon dx to the power of 4 minus sin d cube y upon dx cube, d cube y upon dx cube, which is equals to 0. So here we have to indicate its order and degree if defined. For degree only, if defined, we can indicate its degree also. So already we have solved this kind of a problems in earlier classes. So these are very quite easy. So solution of first one. Solution first one, here we consider first. It is d2y upon dx square plus 5x dy by dx whole square minus 6y minus log x, which is equals to 0. So here highest order derivative present in the differential equation is highest order derivative present in the differential equation is d2y upon dx square, right? Here this term is highest power occurring in that, highest derivative occurring in that differential equation. So thus its order is 2. Thus its order is 2. Now order we got. Next, if it is defined, then we can find its degree also. So the highest power raised to d2y upon dx square is the highest power the highest power raised to d2 y upon dx square is what? 1 only. Its power is what here? Its power is, it is 1 only. So it is 1. Hence its degree is, hence its degree is 1, right? So similarly, second and third one, I will write directly here, second and third. Question number 2. The second one, dy by dx whole cube minus 4 times dy by dx whole square plus 7y, which is equals to sin x, right? So in the second case, if you write it in the standard form again, dy by dx whole cube minus 4 times of dy by dx whole square plus 7y minus of sin x, which is equals to 0. So here, highest order derivative present in the differential equation is what? That is, highest order is dy by dx, right? Here also dy by dx is there, here also dy by dx is there. So thus this order is 1. Order is 1, right? So the power, highest power raised to the dy by dx is highest power, second one. Highest power is 3. Highest power is 3. So its order is its order is 3 because this term, highest order derivative is dy by dx here in this equation and its power is 3. Therefore it's a first order and third degree, right? So similarly, third one, in this equation, d4, this fourth order, it is d4 y upon dx to the power of 4 minus sine d cube y upon dx is equals to 0. So here the highest order derivative present in the differential equation is, highest order is, which implies highest order is d4y upon dx to the power of 4, right? So thus order is 4. Order is 4 here. When we come across to find a degree, here you can say it is not defined. So it is not a polynomial. For degree, let's see, sine of d cube y upon dx cube is there. So it is not in a polynomial form, right? So function sine, we cannot get a differential form here. For trigonometric functions, we cannot have a function like a differential equation here. So the given differential equation is not a polynomial. It's not polynomial equation. Hence, its degree is not defined. Hence, its degree is not defined, right? हम डिफाइन नहीं कर सकते यहाँ पे डिग्री को, राइट, बिकॉज इट इज नॉट अ पॉलिनॉमियल फंक्शन. यूजुअली इट शुड बी पॉलिनॉमियल and free from radicals, we can say. Usually already you are discussed in degree and order of a differential equation definition. So this is order and degree. Now question number 2. Second question. For each of the exercise given below, for each of the exercise, totally 4 examples are there in this bit. Exercise given below, verify that the given function, verify that the given function is a solution of the corresponding differential equation, right? So out of 4, I'll solve any 2, and remaining 2 questions you solve yourself. Already we have solved these questions in the previous exercises. To the solution, first one in that, y, which is equals to a e to the power of x plus b e to the power of minus x plus x square, such that the differential equation is here: x d2y upon dx square plus 2 dy by dx minus xy plus x square minus 2 equals to 0. Here function has been given y equals to, and sorry, and it's a derivative differential equation. Second one, y equals to e to the power of x a cos x plus b sin x, sorry, such that d2y upon dx square minus 2 times of dy by dx plus 2y, which is equals to 0. So we have considered here 2 equations. It is 2 functions are there with respect to their differential equation, corresponding differential equation. So let us consider first one. We will check whether the given function is solution of differential equation or not. So the solution, that is first one, is y equals to a e to the power of x plus b into e to the power of minus x plus of x square has been given here. So differentiating both sides with respect to x. Differentiate both sides with respect to x, then we get, in LHS what we get with respect to x means it is dy by dx. Now a keep outside, that is constant, d by dx of e to the power of x plus b outside, d by dx of e to the power of minus x plus d by dx of x square, right? So here dy by dx, which is equals to a into differentiation of e to the power of x with respect to x, is e into e to the power of x Here e to the power of minus x is there. If we differentiate, it becomes minus e to the power of minus x. So minus into plus minus b into e to the power of minus x plus 2x. Differentiation of x square is 2x, it is right. So now again differentiating on both sides. Because it is second order derivative corresponding differential equation, so we have to differentiate in 2 times. So again differentiating with respect to x on both sides. Let's see what we get here. d2y upon dx square in LHS, which is equals to a e to the power of x as it is here. Again minus minus it becomes plus, b into e to the power of minus x plus of 2x becomes 2. So now substituting the values dy by dx and d2y upon dx square in differential equation. Right? So the given differential equation is right. I'm writing here this side. So the given is nothing but x d2y upon dx square plus 2 times dy by dx minus xy plus x square minus 2. We have considered LHS here, right? It is LHS. RHS is 0 here, so we have to prove 0 by substituting dy by dx and d2y by dx square. If we substitute in this equation, if we get the value which is equals to 0, then the given function is corresponding differential equation which satisfies, we can say. So if it is not equals to 0, then we can say it is not corresponding differential equation of a given function y, right? So let's substitute the values. X d2y upon dx square value already we have here, right? So substitute this a e to the power of x plus b e to the power of minus x plus 2 plus 2 times of dy by dx value already we have here. Substituting a e to the power of x minus b e to the power of x plus 2x minus of x, value of y is already we have value of y, a e to the power of x plus b e to the power of minus x plus x square plus x square minus 2, right? So again, which implies multiply x inside here, ax e to the power of x plus bx e to the power of minus x plus 2x plus of, again multiply 2 inside, what we get here, 2a e to the power of x minus 2b to the power of minus x plus of 4x minus multiply x inside, what we get here, ax e to the power of x plus bx e to the power of minus x plus of x cube plus x square minus 2, right? So after simplifying this, what we get, 2a e to the power of x, 2a e to the power of x minus 2b e to the power of minus x plus of x square plus 6x minus 2. So see the terms here. It is positive. These terms are positive, get cancelled. Again here these terms are negative, get cancelled. If you go on cancelling the term, positive and negative term, you will get 2a to the power of x minus 2b to the power of minus x plus 6 plus x square plus 6x minus 2, which is not equals to 0. So what it implies, LHS is not equals to RHS. So hence the given function is not solution of a. So we can conclude finally. So hence the given function is not a solution of corresponding differential equation. Corresponding differential equation, right? If it is equals to 0, then we can say the given function is solution of a corresponding differential equation. So our next example, it is example 2. Let us consider y equals to e to the power of x into a cos x plus b sin x. A cos x plus b sin x. If you multiply this, what we get? A e to the power of x cos x plus b e to the power of x sin x, right? So differentiating both sides with respect to x here also. Then we get dy by dx del hs, which is equals to a outside d by dx of e to the power of x cos x plus b outside d by dx of e to the power of x sin x, right? So again, which implies dy by dx, which is equals to a. Here you want to we form first function as it is, differentiation of second function, that is cos x as it is, differentiation of e to the power of x is e to the power of x plus second function as it is, differentiation of first one is sin x plus b as it is, first function as it is, differentiation of second function plus second function as it is, differentiation of first function, that is cos x is sin x is cos x. So dy by dx, which is equals to, by taking a plus b common, what we get inside, let's see, e to the power of x cos x plus of b minus a e to the power of x sin x. Can we write like this? A e to the power of x cos x plus b, we have taken these two terms one side and these two terms other side, right? So a plus b is e to the power of x cos x plus b minus a into e to the power of x sin x. Again differentiate. Again differentiate both sides with respect to x. Then we get, let's see what we get here, d2y upon dx square which is equals to a plus b outside, that is constant, d by dx of e to the power of x cos x plus b minus a outside, d by dx of e to the power of x sin x, right? So again d2y upon dx square, which is equals to a plus b as it is. Here again u into v form, first function as it is, differentiation of second function minus e to the power of x sin x plus b minus a as it is. Again u into v form, e to the power of x sin x plus e to the power of x cos x, right? And d2y upon dx square, which is equals to, now take e to the power of x outside here. Inside what we get? A plus b cos x minus sin x. Totally common we have taken outside from these two terms and these two terms, plus of b minus a sin x plus cos x, close the bracket. So now d2y upon dx square e to the power of x as it is outside. Now multiply a and b. Let's say what we get, a cos x, a cos x minus a sin x. Now multiplied a to these two terms. Next plus b cos x minus b sin x. Next multiply b to the next two terms, plus b sin x plus b cos x. B sin x, b cos x minus a sin x minus a cos x. Close the bracket. Now which term get cancelled? Let's see here. d2y upon dx square. The cancelled terms are cancel here. So remaining 2e to the power of x b cos x minus a sin x. It's nothing but d2y upon dx square. So now substituting dy by dx and d2y upon dx square in LHS of given differential. So the given differential equation is LHS, which is equals to d2y upon dx square plus 2 dy by dx plus 2y. Now substitute the values here. 2e to the power of x b cos x minus a sin x minus 2e to the power of x again substitute dy by dx value the value of dy by dx is a plus b e to the power of x cos x plus b minus a to the power of x sin x, right? It is 2 times let's substitute the value minus 2 e to the power of x minus 2 e to the power of x this plus is there here. Let's see, 2 e to the power of x b cos x minus a sin x. Next dy by dx value is here a plus b to the power of x cos x plus b minus a e to the power of cos x, right? If we take e to the power of x common, it is actually plus. It is plus, right? Let's see. 2 dy by dx is nothing but here e to the power of x. If we take common outside, inside what we get here? A plus b cos x plus of b minus a sin x. So plus 2y is there. So value of y is 2 into e to the power of x a cos x plus b sin x, right? So now e to the power of x common take outside from all the three terms. E to the power of x. So now which can be written as 2b cos x minus 2a sin x. If you multiply 2 inside, what we get here? 2b cos x minus 2a sin x. Next minus of 2a cos x plus 2b cos x. If you multiply here this term, if you multiply 2 inside, then we get minus of 2a cos x plus 2b cos x. Next this term, second one. If you multiply this term, what we get here again plus into minus minus 2b sin x minus 2a sin x, right? Close the bracket. Next plus of final term, it is 2a cos x plus 2b sin x, right? Close the bracket. Next, which terms are here get cancelled? Reshuffle. Let's see, e to the power of x as it is. So we can write it here by taking cos x and sin x common, right? So all the terms we will take a cos x common. Inside what we get here? 2b in the first term minus 2a minus 2b plus 2a, right? It is common cos x plus e to the power of x outside. We are taking separately here minus 2a minus 2b plus 2a plus 2b into sin x, right? Now close the bracket. So which is equals to what? Which is equals to 0. Hence the given function is hence the given function is solution of corresponding differential equation. Corresponding differential equation. Next, in this bit only, question number 3 and 4 is there. You can solve yourself. Next, we will solve question number third bit, that is right. So till then, take care, stay at home, stay safe. Thank you.